Hey, welcome to our first day here of the semi-flipped classroom. We're going to be talking about some science skills today. This is what you're going to learn about: the difference between science and technology, the fields of study and big ideas of physical science, the three levels of creating a law, and the four parts of the scientific method. The first thing I want you to understand here is science is a system of knowledge, and that's one of the main things that we talk about here. Science is a system of knowledge. Uh, it's typically going to begin with someone being curious about a topic. All right, that's very important. Technology, or the use of technology, is to solve practical problems. Advances in science lead to new technology. Examples of that would be the telescope. For example, the telescope or the microscope. Those two discoveries there have led to all types of new technology and also new knowledge. Um, Physical science studies non-living things. All right, and that's what we're going to be discussing here: is non-living things. Well, what is science? Chemistry is what you probably already taken chemistry this year, or beginning chemistry. It's composition of structures, properties, and reactions of matter. But let's talk about physics. Physics is the studies of matter and energy, forces, and motion. These right here are going to be the things that we discussed this entire trimester. Okay, this right here is a really big concept, the three big ideas. There's three big ideas. One is matter. When it comes to physical science, we're going to study matter. Matter is volume and mass. Forces. All right, this is forces cause change in motion. Energy. All right, energy is many types and forms. We have thermal energy, moving energy. We have non-moving energy, which would be stored energy, and we're going to talk about those things. Definitions. First of all, we have a hypothesis. That's an educated guess. A lot of times coaches try to make a hypothesis right during the game and decide why that play not working. Someone didn't make their block. That's a hypothesis because that coach has probably played the game several times, has lots of experience playing or coaching, so he has some background knowledge. He has education in it. Theory. Theory is a well-tested hypothesis. A lot of times coaches over the weekend put together a game plan, and that's a well-tested hypothesis. They're going to put together a game plan that is based on things that have worked in the past. So that's where a theory comes in here. Things that have it's well-tested and it's worked in the past. A law. Well, a law is a rule of nature. This is more than anything I could tell you with sports. A law is a rule of nature, means it's never been disproven. And like gravity. Gravity's never been disproven. Okay, with this here, first we want to talk about the scientific method. This is an organized plan for gathering, organizing, communicating information. The goal of scientific method is to solve a problem or better understand an event. Okay, the steps to the scientific method. We want to make an observation. All right, so one of the first things is we make an observation. All right, that's you're going to gain that through your senses. Either you're going to see it, you're going to hear it, you're going to smell it, or you're going to taste it. Um, and during that, we're going to have things that are repeatable observations. Make sure they're repeatable observations. Second step, you're going to form a hypothesis, proposed answer to a question. Hypothesis must be testable. Example of a hypothesis is the reason it's raining is the barometer's dropping. Well, you can test that. You can see, does it rain every time the barometer drops? Test the hypothesis. Well, that's what I'm just saying. My hypothesis was it's raining because the barometer is dropping. Test it. Next time the barometer drops quite a bit, does it rain? What happens when the barometer drops? The other thing I want to go in here is what's called the manipulated variable here. All right, this manipulated variable, it's the part of the experiment that the scientist can change. A lot of times, this right here, the manipulated variable is they call the dependent variable. With that, then, we have what's called an independent variable. Independent variables, an independent variable a lot of times is time, for example. We don't manipulate time. Time just happens. This dependent variable a lot of times is going to be on the y-axis. This independent variable, x-axis. Okay, the last thing we want to do here is form a conclusion. This is the final and fourth step. This is where we evaluate the data from the testing. We analyze it, take a good look at it, and we form the conclusion. From the data, what is our conclusion now? What have you decided from looking at the data? Sometimes it's different than what you expected, and you have to go back and change your experiment again. Okay, I got one, two, three, four questions here I want you to answer. What is the difference between science and technology? What are the fields of study of physical science? What are the big ideas of physical science? And then I want you to differentiate the 3 degrees of creating a scientific statement. And what are the 4 parts of the scientific method? This part right here where I want you to differentiate, that's the hypothesis, the theory, and the law. Down here are the 4 parts of the scientific method. Have fun with it. I'll catch you guys on the flip side.